Okay, good morning to you all. I've given enough time to join. Let's them to join others. While they are joining, we start. I think you can remember the last lecture which we have done yesterday. We have started a new section, that is routing. And switches run routers behavior also we have seen with the video which we have played yesterday. And you know that the hubs and switches, they contribute to create networks, and the routers contribute to connect different networks. So that's what the basic things that we have started. And the same as presentation today also I have opened, and I believe that everybody can see my screen. So before I start the lecture, I think today there's a meeting. I don't know whether you have someone for that. Anyway, so if you have noticed that by the London Tech for a meeting in the university, so those who are invited can participate. That is a simple announcement. Anyway, I have to participate for that meeting, so therefore today evening I'm not doing classes. It is at start at I think around 2:30, right? So that is what about university, and I believe still you didn't get the assignment. Okay, so we have started routing, and I have showed you about the simple routing table, how the source destination addresses are there, because in this layer routing, the routing devices are we call network devices. That means these devices are functioning in network layer according to the OSI model, and also the TCP/IP model, the internet layer. So therefore, the protocol data unit that they use for this communication is data packets. Packet structure, if you look at it has source address, destination address, the data, and cyclic redundancy check to check whether the particular data originally generated is not subjected to any changes, right? To do some verification about the originality of data. So therefore, there is a check RSCS, right? The originality check mechanism is there, right? So if you refer to the routing table, this is a simple routing table, and you can see that it has destination network addresses, like all IP addresses, and the router should capable of interact or the function with the IP addresses. So it is a must, a requirement, and also it should maintain a routing table to keep information about its neighbor routers and the information about the network. So those things we have discussed, and then we try to understand the classification of routing. That is static routing and dynamic routing. Mainly the static routing is all the routers have to have their routing table configured, and they should manually updated. But in dynamic routing, it is not necessary. The routers communicate with each other to share their routing information with each other. So according to the information shared with among themselves, the dynamic routing also classified into different categories. So those classifications also we have remind you. So the static and dynamic routing are the main division of routing. So then we understood about we try to understand how the routers are communicating each other and update their router table. So we discussed this one. So I'm going quickly. So then we understood that all the routers are sharing their information about their neighbors, and they updated their router tables individually, and they complete the information all about themselves, and it will be utilized to do the communication among themselves, right? And this is where that call convergence, that also we have discussed the time that they have been taken to aware about the others and themselves, right? So then we have discussed the classification, further classification of dynamic routing. The dynamic routing can be divided into two categories, that is distance vector and link state. And we try to understand how the distance vector behave and how the link state behavior. The distance vector routers, each routers communicates all the networks it knows about to other routers to which it's directly attached, and the communication will be taking place on a regular basis. So therefore, we have discussed some of the disadvantages they get because of this behavior. High traffic will be generated because they do broadcasting among within those networks, and also when they communicate each other, the line communication lines are exhausted with this communication, regular communication. So therefore, for other communication, it will be a barrier or a problem. In link state routing, it's entirely different. Initially, what they do is they map the entire network, and they are not doing any communication periodically like distance vector routing. And also whenever they want to communicate, it's only happen when there's a change has been made to the network. So therefore, very rarely these updates are happening. Especially they use for this communication uh, uh, link state advertisement. So it's a packet that is going here and there and transfer the information updated due to a change that has been take place within the network. So therefore, minimal time they are being taken for information sharing among themselves. So because of that, with respect to the distance vector routing, the link state routing is very efficient routing. We consider like that, right? So further, we divided the distance vector protocols routing. We can confine different categories. Initially, the initial stage, the routing distance vector routing protocol that we have used was RIP, routing information protocol. If you look at the characteristic of RIP version, the initial version has support maximum 15 hops. That means up to 15 routers he can keep information with this routing table, and he knows to that extent about his networks. Originally had updates sent every 30 seconds. So these are the regular updates are happening like this. Every 30 seconds they do updates those information. and does not support authentication, that password authentication. Uses broadcast communication. So broadcast communication is not a efficient communication system. It will create unnecessary traffic. Then after that, the evolution of RIP, they introduce a new version, that is RIP version 2. The same characteristic, still they provide the support for maximum 15 hosts, and they support for authentication also due to these changes. And they, instead of broadcast communication, they use multicast communication. So multicast communication is a one-to-many communication. So therefore, it is more efficient than the broadcasting, that is one-to-many communication. Sorry, one-to-all communication. So the BGP is another distance vector protocol, and it is called border gateway protocol. And most of the time, as I said earlier, it is always between routing protocol which is used in the internet in the core routing. That is, it is in between most of the autonomous system, especially in between the internet service providers, right? So then we discuss about the other category, that is link state routing. There are two types, OSPF and ISIS. So the OSPF use a medium to large networks and based it path of link state. That is, if a particular link's state has been changed in the network, so then only they will do the link state advertisement and update the latest information about the neighbors, and can also the cost metrics to give the preference to the certain paths. That means they find the shortest and the most critical path, or that means the most open shortest path first, and they do the routing accordingly. So because of that, it is more efficient than the other routing protocols. And also the intermediate. So intermediate system means again a router. So intermediate system to intermediate system, that means router to router communication. So intermediate system is another name for router, and originally you designed with the OSI model, but this is not used frequently, very rarely use it. Then we discuss about the hybrid protocols. Actually, this protocol we have to discuss more in depth because sometimes the assignments might ask more questions based on this hybrid routing protocols. So therefore, studying very deeply on this routing protocol is very useful for your assignment in some way. So therefore, we should know that what is hybrid means. Hybrid means the regular protocols like distance vector and the link state routing protocols. Common characteristic have been taken to this enhanced interior gateway routing protocol. So it's evolved from interior gateway routing protocol, IGRP. It also uses algorithm, and that means just like in OSPF, they use shortest path first measuring algorithm. So likewise, similarly, the EIGRP also using a diffusing update algorithm, and the router keeps a copy of its neighbors' routing tables, and each router periodically send out the hello packet, just like the link state routing protocols send link state advertisements to their neighbors. So to keep the track of the state of its neighbors, right? So therefore, these are some of the similarities or the common characteristics to the other routing protocol. That means they have studied the distance vector routing protocols and link state routing protocols, and they have chosen some of the common features of them, and they have incorporated with the enhanced interior gateway routing protocol. So therefore we call it, since it has a hybrid characteristic of both the distance vector and link state routing protocol, we call it hybrid routing protocol. So before we wind up the session, last day, that means to yesterday, we have come across this word that is convergence. Convergence means, now you can understand, earlier also I have explained, because the routers characteristic is they always try to aware themselves. Some routers are regular basis according to their routing protocol. Some routers are initially they map the entire network, but later on, whenever there is a change in the state of links in the network, so then they will do communication with the link state advertisement. So for this process, that means when changes are made to a network, every router on the network will need to make an appropriate changes to their routing tables in order to accommodate the changes. So this could be addition or deletion of a router, or could simply be a change in metrics for a path. That means if a link has been gone down, so the initially calculated paths for the destinations, the metrics that they have subjected to change. So this change should be sometimes addition or a deletion of a router, or could simply be a change in metrics for a path. So the conversion is the process of all routers becoming aware of changes to a network. So convergence means it's a process and of all routers becoming aware of changes to a network, right? So that is the meaning of convergence. And there's another word called convergence times. So to happen this process, it will take a considerable time. So that time we call convergence time, right? I think it is clear for you. So initially we have classified the routing protocols into two different categories, that is static routing and dynamic routing. Then after that, the dynamic routing also we have divided into two parts, that is distance vector link state. Then the distance vector routing protocols we have recognized, RIP and IGP, likewise, and RIP version 2 in the BGP. But now we are going to categorize based on the routing protocol function within automation system and outside the autonomous system. Within autonomous system and outside autonomous system. Now, normally the interior gateway routing protocols are used to exchange information between routers within a local area network. The exterior gateway protocols, the routing protocol used to route information outside the local network and typically out to the internet. Most probably in between two autonomous systems, like in between two internet service providers. So therefore, this type of categorization also we can do for the routing protocol categorization. So keep in mind that also how the interior gateway and exterior gateway are differentiate when we are discussing about routing, right? So then we'll try to understand what is a router means. At the center of a network is the router, and state simply a router connects one network to another, right? So that is the simple understanding about router. So the routers are responsible for deliver of packets across different networks. That is one of the major role that the router is playing. So he's responsible to deliver packets because, as I said earlier, the router is functioning in the layer 3. So he's always use packets, that is protocol data unit he uses for communication is packets. So therefore, he has to deliver packets he received from different networks to across different networks to the other side, the destination side. The destination of the IP packet might be a web server in another country or an email server on the local area network. So that is possible. So anyhow, the router has to have some capabilities of reading IP packets and understanding and keeping them in their router tables. And whenever a packet received for a particular destination known by the router, it should direct or route it to the correct destination. That is the main responsibility of router. So the router is the responsibilities of the router is deliver those packets in a timely manner also, because if it is delayed, so then that also not expected from a router. The effectiveness of the internet communication depends to a large degree on the availability of routers to forward the packets in the most efficient way possible. Now, if you imagine that the internet, the cyberspace, it is mostly made up of thousands of routers. So if these routers are not doing their job accurately, so the ability of forwarding the packets in the most efficient way is not possible. So therefore, the router is playing a vital role in cyberspace or internet, right? So the latest news about routers is, you know that the routers are now being added to satellite in space. So these routers will have the ability to route IP traffic between satellites in space, in which in much the same way the packets are moved on the Earth. So thereby the reducing the delays and offering greater networking flexibility, because if you can remember that somewhere in 90s, one of the sea cable, that is undersea cables, one of the cable has been broken, which is entering the Sri Lanka, where the call somewhere in Moratuwa, not Moratuwa actually, Kalkis, I think, somewhere. It is very close to.
It's
Sorry?
in Paduka, right? Paduka.
That is the satellite center, I think. The sea cables are entering into the
That's in
Sri
Mount Lavinia,
Lanka. Yes, it is Mount Lavinia, no?
Yeah, Mount Lavinia Telecom. It's in the
Yes, Mount Lavinia. So that is the place where the cables are entering into the country. And there are some restrictions also, that is some of the large boats and others equipments cannot move from those areas. So it will damage the fiber optic cables which are laid, because the depth of the cables are very less when it comes to the beach side. But in the deep sea, it is not a problem. But when it comes to the lower level, so it will be problematic. So that's why they have restricted those areas. But anyway, in that occasion, the satellite was the major source that the internet could provide to Sri Lanka. So otherwise, there was, I think, nearly 1 month out of internet, right? But now it is not like that, because we have many cables, CME V3, CME V4, CME V5 also there, I think. Singapore, from Singapore to Sri Lanka, from Sri Lanka to India. So SLT also maintaining some cables, Singapore also maintaining some cables. So likewise, multiple connections are there. So because of that, we don't have to worry about it. Redundancy is very high now, not like earlier. So, and so therefore, the routers are now in space also. And the other thing I have to tell you is another new concept is coming about internet, that is interplanetary internet. I don't know whether you have heard about it. Nowadays they are testing for a new protocol because nobody has found any suitable protocol for interplanetary internet because people like going to build villages, cities in moon as well as Mars. So therefore, whenever now there was a young lady that she's always already prepared to go to the Mars, and she never expect to come back to the Earth again. So likewise, people dedicated their lives to um, overcome the establishing of villages in Moon and the Mars. So then, if they succeeded in that case, so then we have to have a protocol to facilitate internet connectivity. So therefore, now they have come up with a good, I mean, a new concept called interplanetary internet. So therefore, nowadays they are seeking appropriate protocol for that, right? So now you also can think about it. What is the appropriate protocol for interplanetary internet? Because we have planet internet. So in the Earth, we can only use those protocols. But when it goes out of the planet, how the protocol should be, and that is called interplanetary internet, right? So it's sometimes the routers may have to modify, and we have to introduce the new protocols to the routers also sometimes. I don't know. That is a new concept actually. We have to think in a novel with a new way, and we have to find out a way to succeed in that attempt, right? So the routers. Further, we discuss to meet the demands on today's network, the routers are also used to ensure that the high availability, you know that the high availability is measured by the 99.999, like that means the minimum downtime of any network, because you know that when we discuss about topologies, the internet has mesh topology. That means internet is the wide area network. So if it has a mesh topology, we know that it has a high redundancy. So and also the health of the router is also very important to guarantee a 24 by 7 service to the people who use the internet. So to help the guarantee network reachability, routers use alternative paths in case the primary paths fails. So whenever the original path is not available, so they have to use alternative paths to route the packets to the destination very efficiently. So therefore, router is playing a vital role when providing 20 by 7, 24 by 7 service to the human beings, right? And provide integrated services of because when we get networks, they have three types of traffic. One traffic they move is data. Another traffic they move is video, and another traffic they move is voice. So these three types of services are integrated sometimes and provide. So it might sometimes it's over wired networks, sometimes it's over wireless networks or guided networks or unguided networks. So the router use quality of service. That means since it incorporate with different services like data, video, and voice. So according to the requirement of the organization, so we have to prioritize it, and so prioritization is of IP packets to ensure that the real-time traffic, because sometimes some organization they need the voice to give the high priority. Sometimes some organization like media organization, they sometimes give more priority to the videos, and sometimes the news organizations, sometimes they give into the information. So because of that, they have given more priority to the data. Organizations also, they have given more priority to data sometimes. So likewise, sometimes the voice is more critical. So therefore, in configuration of routers, they have given high priority to the voice over the internet or Ethernets. So the when we are talking about switches, we discuss about the PoE switch, that is voice over IP. So that is there we have to give prioritization in router configuration, that which traffic should be given priority to ensure the real-time traffic. And such as the voice, video, and critical data are not dropped or delayed. So it is an impact to the organization's services, and mitigate the impact of worms, viruses, and other attacks on the network by permitting and denying the forwarding of packets. So that is means sometimes the router itself, there is some firewalls embedded. That is what the integrated solutions having. Sometimes it's not a separate solution. Sometimes the routers are integrated with the firewalls, and it doing a firewall mechanism also with filtering data, right? So sometimes you may wonder that what is the router and how it is functioning and how it is look like. Actually, a router is a computer, just like any other computer, including a PC. And it is a very fast, very first router used for the advanced research project agency network. That is, if you can remember when we are discussing about the DARPA model or the TCP/IP model, that model was introduced to the network industry by USA, and they were initially used these protocols in this advanced research project agency network, right? So that is called ARPANET. So this is the first network which was established in the world. So then it was later on commercialized. So the interface message processor, IMP, and the IMP was the Honeywell 316 mini computer. So this computer brought the ARPANET to life on August 1969. Now you can imagine that what is the age of the internet and how it has been evolved for the today's status from 1969. Right. So the ARPANET was developed by Advanced Research Project Agency of United States Department of Defense, and the ARPANET was the world's first operational packet switching network and the predecessor of the today's internet. So now you can understand that, right? So routers have many same hardware and software components that are found in other computers, including it has a central processing unit, it has RAM, ROM, and operating system also. So that's why it is called a computer. I don't have now the video clip. Later on, I will find out and show you. It will take some time, so therefore I go to the next slide. Each network that router connects to typically requires a separate interface. So these interfaces are used to connect a combination of both local area network LANs and wide area networks. Now you can understand why these interfaces are available in a router. Because router is the intermediate device which is connecting different networks. So most probably the one side of the router will be a local area network, and the other side of the router might be a wide area network. So therefore their interfaces are different according to the connection combination, right? The LANs are commonly Ethernet networks that contain devices such as PCs, printers, and servers. You know that if you take a LAN, local area network, most probably the devices might be PCs, printers, and servers. But when you take WANs are used to connect networks over a large geographical area. WAN is used to connect networks over a large geographical area. So that is why we call it wide area networks. So sometimes in a wide area network, you can find different technologies. Some are wired, some are wireless. So likewise, so it's a collection of different network technologies, right? So for example, WAN connection is commonly used to connect a LAN to the internet service provider network. So that is where the WAN connection comes. Routers actually determine the best path, right? So better to know about it. The primary responsibility of a router is to direct the packets distinct for local and remote networks. By one thing is to determine the best path to send the packets, and then it has to forward in the packets towards their destination. So why the router need to find out the best path? Because routers are connected with multiple channels. So sometimes if the router has chosen a long path, so it will impact to the time that the particular packets reach the destination. So therefore, sometimes unnecessary delays might come, and because of that, the efficiency of network communication dropped. So in order to overcome this problem, the routers have the capability to determine the best path to send that receive packets to the destination. So the routers uses its routing tables to determine the best path. As we seen in the video, always the router maintaining a router table, and it's forward the packets, right? So when a router receive a packet, it examine its destination IP address and then search for the best match with the network address in the router's routing table. So the routing table also include the interface to be used, that is to forward the packet. And once a match is found, the router encapsulate the IP packet into the data link frame of the outgoing or exit interface, and the packet is then forwarded towards its destination. Actually, that means if I refer to the earlier tables again, you can see that here there are some destination IP addresses in this router table, and also it is having the information about the appropriate interface to which interface this particular packet should be routed to reach this desired destination. And also he knows in advance, So how many hops he has to pass out to reach this destination. So those information is also there. So therefore, it is easy for him to determine the best path to the particular destination according to the hop count. Right. Sometimes some of the routers, they use different techniques to find out the techniques to determine the best paths to the destination, right? And also the routing table also include the interface to be used for the forward packets. That's what I showed you. And once the match is found, so when the matching destination found, the router encapsulate the packet into the data link frame of the outgoing and exit interface, because interface is also mentioned in the routing table, and the packet is then forwarded towards its destination. So that's how the routing is happening. So this is the appropriate picture to show you that a router has different interfaces according to the LAN links and the WAN links. So for LAN links, it has RJ45 interfaces. So you know that the UTP cables have RJ45 connectors. So these RJ45 connectors are connected with these RJ45 ports, right? That is LAN links. And sometimes you want to connect with WAN links also. That means router. So routers are connected with DT cable for these serial interfaces. So that's why both these interfaces are available in a router, right? So this is hardware components of a router to emphasize you that router also like computer. Because you can see that it has a CPU like in a computer, and it has memory cards, and it has a CPU bus to travel data from one point to another point, and it has a booting mechanism. It has ROMs and RAMs, and it has a operating system also, that is iOS, right? So likewise, router just like a PC because of these characteristics. The central processing unit, random access memory, and read-only memory is there. So CPU execute the operating systems instructions such as system initialization. Now, whenever you purchase a new router, so first of all, we have to power up it, right? And we have to look at whether this router is working or not. So when you give the power to it, the router, so it will start to execute. So normally we never directly plug the routers to the network. So we have to test it offline whether there is any issue, because sometimes when we supply the power to the router, because of a defect of the router, sometimes the entire power system will be damaged. So in order to overcome that problem, what we do is initially we power up the router, and we check whether it is okay to connect to the network. So after that verification, we can ensure that it will not generate any issue with respect to the power. So we can power up it without any problem. So that's how when you are doing a network project, the deployment of routers will be happen like that. So then only we know that it will not create any trouble to the network, right? And if you look at some of the components, one component is the CPU, that is CPU execute operating system instruction, such as initialization, routing function, and switching function. Then RAM, if you look at of a router, RAM stores the instruction and data needed to be executed by the CPU. So why I am discussing these things, because if you are very apprentice to this area and if you don't know about the router and what is inside the router, so that's what I'm exploring these areas, right? So it has operating system, as I said. So if it is a Cisco router, it has Cisco ISO, that is Internet Operating System, and it is always copied into the RAM during the boot up, because when you switch on a PC also, it's first it's direct to the startup process, that is boot up process. So then similarly the router also, like computer, and it's also running like this, and first it is copied the RAM, the Cisco ISO to the RAM during the boot up. So the running configuration file. So this is the configuration file that stored the configuration command that the router ISO is currently using. Because normally, if a router is already a configured router, so definitely it has this file that is running configuration file. So this configuration file contain all the configuration which has been done to the router. So as a security measure, most of the time, if the router has critical configuration details, so best practice is to get a copy of the configuration file and keep somewhere. Then suddenly, if it is corrupted or any problems got, so then we can refer the backup and we can restore the backup again to resolve the problem. So the configuration file that is stored the configuration commands that the router IOS is currently using. So with a few exceptions, all commands configured on the router are stored in running configuration file known as running config here. We say it running config. So if IP routing table, if you look at, so this file stores information about the directly connected and removed networks. So and it is used to determine the best path to forward the packets. So that is how the RAM is working within a router. Then another mechanism in a router is ARP cache, that is Address Resolution Protocol cache. So this cache contain IPv4 addresses, that is to map with the MAC address, and similar to the ARP cache on a PC, right? So PC also having a ARP cache, because if a PC want to find a destination address which is unknown, so firstly what it's do is send a ARP request to the destination PC and get the entire information from them, right? So the ARP cache is used on routers that have LAN interfaces such as Ethernet interfaces. And also it has a packet buffer, that is packets are temporarily stored in a buffer when received on an interface or before they exit an interface. And RAM is actually a volatile memory and loses its content when the router is powered down or restarted. However, the router also contains permanent storage areas such as the ROM, flash, and the NVRAM, right? So if you look at the ROM is the form of permanent storage, as we discussed earlier. So this Cisco device use ROM to store the bootstrap instruction during the booting process, how it should be react, and basic diagnostic software and scale down version of iOS. And ROM uses firmware, which is software that is embedded inside the integrated circuit. And the firmware includes the softwares that does not normally need to be modified or updated, such as the boot up instruction. And many of the features included in ROM monitor software will be discussed later. And the ROM does not lose its content when the router loses power or is or restart. So therefore it is not like the RAM. Remember we discussed that it is volatile and non-volatile thing. So this is actually RAM is volatile memory, that is losses its content when route is powered down or restart. But ROM is not volatile, that is non-volatile, right? Not lose its content when the router lose power or restart. Then flash memory. The flash memory is non-volatile computer memory that can be electrically stored and erased. The flash is used as a permanent storage for operating system. Cisco IOS, in most model of Cisco routers, the IOS is permanently stored in flash memory and copied into RAM during the boot up process. So now, if somebody asks that where the operating system is stored, so you can now you know that it is stored in flash memory. And during the boot up process only, that particular IOS coming to the RAM and do the boot up. So where it is then executed by the CPU, and some older models of Cisco routers run the IOS directly from the flash. And the flash consists of SIMs and PCMCIA cards, which can be upgraded or increase the amount of the flash memory. That means the capacity of the flash memory. So NVRAM is also a non-volatile RAM. It does not lose its information when power is turned off. So it's better to remember. And this is in contrast to the most common forms of RAM, and such as DRAM that requires continual power to maintain its information. The NVRAM is used by the Cisco IOS as permanent storage for the startup configuration file. And all the configuration changes are stored in the running config file. Earlier also we noticed this, and in RAM, and with a few exceptions are implemented immediately by the iOS, right? So to save those changes in the case the router is restarted or loses the power, the running configuration must be copied to the NVRAM. Now look at that, right? To save those changes in case the router is restarted or loses power, the running config must be copied to NVRAM, where it is stored as the startup config file. So the NVRAMs retain its content even when the router reloads or is power off. So that's why the NVRAM is very useful, and it is called a non-volatile RAM because it will not erase any information though it is power offed, right? So we have come to 1 hour. So we'll look at how the boot up process is happening in a router for your information. But until then, I think you are hungry. Some people are not taking their breakfast. So for a quick breakfast, I will give you a 10 minutes break, right? So we'll come back again 9:40, around 9:45, and we'll continue the lecture. Okay? Are you all right? Shall we have a break?
Okay, sir.
Yes.
Okay. Yes. Okay. With the breakfast, right? We were discussing about what do you call discussing about the router's different components, and so we stopped somewhere in boot up process. So whenever you switch on a router, boot up process is begin. So there are 4 major phases to the boot up process. One is first it's performing the POST, and then the post mechanism in just like in a PC, and then loading the Bootstrap program and locating and loading the Cisco or whatever the software that is using by this device, and locating and loading the startup configuration file and entering the setup mode. Right. So the router interfaces can be divided into two major groups. One is LAN interfaces, as I showed you in the picture, that is for Ethernet and fast Ethernet, and also WAN interfaces such as serial, ISDN, and frame. So this is inside the router when a bootstrap boot up process is happening. First, perform the post, then the bootstrap, that is execute bootstrap load, then locate the ISO, and then load the ISO, then locate the configuration file, and then execute the configuration file, and then enter the setup mode. So this is the router communication taking place in between two nodes. So in between these two PCs, PC1 and PC2, you can see that there are three routers, namely R1, R2, and R3. So you can see that how these routers are functioning with respect to the OSI model. Actually, when you take a PC, it is representing all the 7 layers. But when you take a router has only 3 layers. So that means the network layer is the layer which is running in the router, functioning the router. That is what it has been shown in this red arrow line. So whenever the data received from the PC and it is connected with the physical layer, and it goes as electric pulses, and it's go to the physical layer of the router, and then the data link layer of the router, and then it's moved to the network layer. So that is the data packets can be handled. That means that is the PDU that they are using, packet data unit. And again, if there's another router, the same way. And then when it's reached the destination, so like source PC, the destination PC also behave in the same way. So this is the red arrow indicate flow through the OSI layers. So basic router configuration, if you look at when configuring a router, a certain basic task we have to perform. One thing is when the very first stage, the router has no any name. It has the default name that has been given. So then the name the router is very important to do the configuration later on, and we can give very sensible name for that to recognize it very easily. And according to the classification of routers in your organization, that's also possible. And we can put authentication to the router, because in security wise it is better to have it for to avoid unnecessary security breaches. And also the configuring the interfaces. For example, for communication, we have to give IP addresses to the interfaces of the router. So therefore, we have to configure the network interfaces of the router. And sometimes some useful banners we have to use, and we have to save the changes on the router, and we have to verify the basic configuration and router operation. So for your information, these are some of the basic router parameters. So when you want to name the router, you can use you can go to the configuration mode, and you can give this name, the router name, that is the host name. There is the command, host name, and the name. So all these things should be in a executable mode. So before I go further about this configuration basics, I have another presentation about the configuration standards, right? So I will go with it, and then after I come back again to my previous presentation. So it is necessary for you to know the basic things about configuration. Right. Okay, I'll go through that. This is very important you to know when you are handling a router. Say just a minute. You know that if you take operating system, it has outer shell, kernel, and hardware. Some of them you know very well. Now, if you take a shell, the user interface that allow the users to request specific tasks from the computer, right? And requests can be made either through CLI or GUI. So when you take an interface, there are two types, CLI mode and GUI mode. And the CLI mode means the command line interface. So you can't see any graphical user graphical interface there. Only the text mode commands you can find there. CLI mode, very preliminary interface. But when you goes to the GUI mode, GUI interface has a geographical user interface has icons and command line. No need to type command line interfaces, interface commands. So you can easily interact with the interface. It is more user friendly than the CLI mode, right? So the and also the kernel means the communicate between the hardware and software of a computer and manage how hardware resources are used to meet the software requirement. So if you don't know about any idea about the kernel, so the application cannot directly run with the hardware. So therefore there should be a kernel for that, right? The hardware is the physical part of a computer, including underlying electronics, right? So let's see that some of the access method of router. The advantages of using console, because there are three way of accessing router. One is directly you can connect to the console of the router. Console means you can see here. So this is the port where you can connect to the router. You can see that it is saying as console, right? We have to use it for rollover cable or console cable for this. When we are doing twisted pair cabling, like straight cable, crossover cable, and we have learned about rollover cable, right? So that is console cable. Okay. So by using the console port, we can connect to a router. The advantages of using a console port is that the device is accessible even if no networking services has been configured. So therefore, you have to know that in what situation you choose this method, right? Now, this is the situation where you use the console port. That is the advantage is that using a console port is that the device is accessible even if no networking services has been configured, such as when performing an initial configuration of a networking device. So initially when you are configuring a device, so better to connect through a console. And when performing an initial configuration, a computer running terminal emulation software is connected to the console port of the device using a special cable. That is configuration commands for setting up the switch or router can be entered on the connected computer. So therefore, normally we use a laptop for this purpose. And the other access method is telnet. The best practice dedicates to use SSH instead of telnet for remote management CLI connection. Why? Because telnet is not a safe mode. It is not communicate with encrypted environment. So therefore, they recommend instead of telnet, SSH is the sequential connection is the most appropriate, right? So therefore, the Cisco IOS include the telnet server and telnet client that can be used to establish telnet session with the other devices. But anyway, the recommended one is the SSH. In a telnet software also, you have been heard that PuTTY. PuTTY is a very good software. So there you can find the SSH connection and you can use it. The SSH connection is recommended method for remote management because it's provide a secure connection. The SSH provide the encrypted password authentication and transport of session data. So therefore, it is more secure. This keeps the user ID, password, and details of the management session private. And most version of the Cisco IOS include an SSH server and SSH client that can be used to establish SSH sessions with the other device. So this is the secret where we use the SSH instead of telnet, right? I can show you the PuTTY configuration terminal. It's a terminal emulation program. You can see that here we can use both the telnet also we can use, or we can use SSH, and we can type the host IP address here, and we can type the port also that we want to access it, right? And we can access through this port securely because we are using the SSH channel, right? So this is the mode of operation of Cisco router. The console connection must be established before an initial configuration of a Cisco device. And after being consoled in the network session, we'll have to navigate through the various command modes of the ISO CLI. And then the ISO mode uses hierarchical structure and are quite similar for both switches and routers. So this the hierarchical structure for IS modes are quite similar for the both switches and routers. You can remember that, right? So this is the primary command modes. You have to know this before going for a practicals in a packet trace also. How this the primary command modes are being executed. The user execute mode is the limited examination of router and also the remote access. So therefore, the user execute mode allow only a limited number of basic monitoring commands and is often referred to as a view-only mode. It is a user execute command is a view-only mode, right? So it has limited number of basic monitoring commands. Now, when it comes to the privilege execute mode, now I'm discussing for both switches and routers, right? When you are log into the router or a switch, so you have to go through these two modes, right? But when you comes to the configuration part, you can't do it with the user execute mode. You have to have privilege execute mode. So detailed examination of router, that is debugging, testing, or file manipulation or remote access. So you have to use privilege execute mode. Privilege execute mode by default and allows all monitoring commands and as well as execution of configuration and management commands. For configuration commands, the global configuration mode. To configure the device, must enter this mode with configure terminal command. Example, configuration command modes. That is global configuration mode. To configure the device must enter this mode with configure terminal command. Example, that is switch and config the hash mark. So these two modes you have to understand. Now here you can't see the hash mark in front of the front of the switch or the router in CLI command mode. But here, of course, when it comes to the executable privilege mode, the hash mark will be there. So that means it's indicate that you have in a privilege mode, not in a user execute mode, right? So likewise, when you log into a switch, you have to log into the both the user execute mode and the privilege mode. But when you want to do the configurations, definitely you have to go to the privilege mode. So in global configuration mode, there are some configuration modes also. That's what we have discussing. So the example configuration terminal is the switch, right? If you are logged into a switch, so and if you are in a executive privilege execute mode, so then the prompt should be like this for configuration, switch config. The CLI configuration changes are made that affect the operation of the device as a whole. For this mode, the user can enter different sub-configuration modes. That is two common sub-configuration mode include, that is line configuration mode. Line configuration mode used to configure console, SSH, telnet or aux access, example switch config line. Interface configuration mode, it is used to configure switch port to router network interface, example switch config if mode, right? Okay, so this is the navigate between ISO modes. Whenever you log into the switch or a router, so this screen will be appear. So there, if you have already given a password for the privilege mode, so they will ask the particular password. But otherwise, the default password is there, right? So you can give enable the executable privilege mode, and then if it is password is there, sometimes the default password might be Cisco or the same enable, right? And then by disabling, you can again comes to the use the executive mode prompt, right? So this is the primary level of execution of router in a CLI mode, right? So in a switch also the same way, you can see that enable and then configure terminal. You can give the command configure terminal, and then the prompt will be changed to this prompt print mode, this mode, and you can give the interface the VLAN 1 and then exit. So this is the default LAN that we are using in the switch. And this command you can see that's also the same way. You can see the navigation between the ISO modes. So this is the basic ISO command structure. You can see that whenever you log into a switch, there's a switch prompt is there. So sometimes according to the name that you have given to the switch, that name will be appear here. And then you use a command for this particular switch configurations. And then definitely there will be a space and there will be a keyword or a argument, right? Prompt is there. We use then command in front of that, and we use a space, and then we give a keyword or a argument. So this is the standard way of writing commands on a CLI mode when you log into a switch or a router. So that is what I wanted to highlight. So when you go to a interface, you can practice these things in a packet tracer. You can put a switch and you can log in CLI mode, and then you can enable the executable mode, privilege mode, and then after that you can use these commands and you can practice them, right? So this is how the set the clock of the switch, and this is one of the commands. So don't worry about this because if you go to the Cisco site, almost all these commands are available. You can search and get it in a notepad, and you can practice them as much as you can and familiar with them, right? And also a lot of videos are available in YouTube for basic configuration of switches and routers. So then you can use those videos also to practice. But this theoretical standard theoretical background is very important to you. Now, for example, if you know this command structure, you never make any mistake when you are typing the commands in front of a prompt, because you know that how this command should be followed and what is the standard structure of them. So therefore, you know how to correct by yourself and identify your mistake and give the command in a correct way. And also you can use the tab if you don't know the some of the command. You can, if you can't remember the entire command, so you can type 1 or 2 letters and you can type the tab button. So then it will give the command the other remaining letters. And also you can give a unknown command 1 or 2 letters and can give a wildcard like question mark, and you can find out what are the command available related to that type of a word. Likewise, you by yourself you can familiar with the command execution. These are some of the keys that is tab. As I said, complete the remainder of partial type command or the keyword. So that tab is very useful. And if you want to redisplay a line, so that is Control R to move the cursor from move cursor to the beginning of the line. That is Control A. Exit the configuration mode and return to the use execute mode. So Control is set. The down arrow allows the user to scroll forward through the former commands. Up arrow allows the user to control back through the former commands. Control Shift 6 allow the user to interrupt the ISO process such as ping or trace out. Now, if you have executed the command like continuous ping, so then you can interrupt it. Control C, that is to abort the current command and exit the configuration mode. So that's also some of the shortcuts or the hotkeys which where you can see use in practicals. So this is an example for configuration of a host name in a router or a switch. The same way you can use. You can give in the privilege mode the configure terminal. So then the prompt will be changed into according to the device, the configuration mode, and then you can give the command now according to the DC structure. The command you have to type. So here the command is the host name, and you have to give then according to the there should be a space. So definitely there will be a space, right? There will be space, and then you have to give the argument or that keyword, right? So you can see the argument, that is the name for this host name has been given as SW flow1. So then after the execution of this command, so this the name of the switch has been renamed to the given host name, that is SW flow1, right? So that's how the host name is given. Now we look at how to go to the privilege mode, and you can see some example here: enable and config terminal, enable secret class. So then the execute use execute password example and VTY line password example. Right. So these things are in the presentation. Right? So this is service password encryption. Enter the command to encrypt the plain text password. So you can see that show running config. So then the password is encrypted, right? Prevent the password from showing up as a plain text when viewing the configuration. This purpose of this command is to keep unauthorized individual from viewing password in a configuration file. After this command is applied, the removing the encryption service does not reverse the encryption. So this is how to show a banner. Why I am doing these simple things, because some people are more apprenticed to this interface. So therefore they can try out these small things in the packet tracer. Because initially when I'm starting these lectures, I have showed you how to create account of packet tracer by using a small video clip. So then you know now how to do it. So then you can have a content, a very free account you can have. You can go to the Cisco site and can go to the packet tracer and packet tracer section, and you can make a create a sign up with the packet tracer, and then after that you can have a account. And if you like to practice some basic instruction about the packet tracer, there is a small course, so that also you can follow, and you can familiar with the packet tracer, right? So after familiarize with the packet tracer, you can try out these small exercises to familiar with the CLI mode. So here these are an important parts of a legal process in an event that someone is prosecuted for breaking into a device. So that is here you can see banner mode. This is a secure system authorized access only. So if someone is unauthorizedly try to access this device, so this banner should be appear. So that is the intention of putting this banner. So likewise, you can use banners for readability to enhance the readability of commands. And when you are doing a running configuration file, I mean, when you want to save after configuration, the configurations to the router, here you can go to the command list the complete configuration currently active in RAM by using this command, that is show running config. So it will show the configuration that is available now. File stored in NVRAM, that now you know what is NVRAM because I have introduced what is NVRAM. NVRAM that contains all of the commands that will used upon startup or reboot. The NVRAM does not lose its content when the device is powered off. That's why we call it non-volatile. So all these things we have discussed. Therefore, it is not a new thing for you. And the active configuration can be copied to the NVRAM. So this is the command copy running config startup config, right? So this is how copied the configuration to the NVRAM. So altering running configuration, that is restore the device to its previous configuration by removing change commands individually. So copy the startup configuration file to running configuration with the copy startup running config privilege execute mode command. And to reload the device with the reload command from privilege execute mode, you can type in front reload. So then the system configuration has been modified. Then it will ask save. So then you can give no. Then proceed with reload. Then you can confirm it. So this is the configuration of IP that is in a device. So for Ethernet adapter properties, you know that in a PC, this type of a interface dialog box will become. So you can select the appropriate version of IP, either IP version 4, IP version 6. So then after that you can assign the manually the IP address and the subnet mask. Now you know because you have done the IP addressing. And this is actually a class C address, and the default gateway to go to direct the computer information outside of its network. So therefore there should be a default gateway, and also if it is using internet, so we can give the preferred DNS server according to the ISP that you are using, right? Internet service provider, if you are using, you can give a preferred DNS and also alternative DNS if the preferred DNS is not available. So this is how the automatically configure IP address. So this is called sign-in dynamic addresses. So there you have to select the obtaining an IP address automatically. So therefore there should be a DHCP server, dynamic host configuration protocol server, which is deploying IP address dynamically to the devices connected to the network. So then this particular device can catch up one of the dynamically issued IP, and they can use that IP for the communication further. So this is how the automatic IP address configuration for end devices. You can see that how this automatic IP has been taken, right? So it's not a it has both IPv4 and IPv6 addresses. So here the configuration of virtual interface of a switch, that is IP address together with subnet mask uniquely identify end device on a network. The subnet mask determine which part of a large network is used by this IP address. And the interface VLAN 1 is the interface configuration mode. So we for giving to identify the LAN, and the IP address is given like this way. The first we have to give the command IP address to assign the IP to the interface, and then you have to give the decimal notation of the IP. Then after the everywhere there's a space, and that means after IP there's a space, after address there's a space, then after the decimal notation of IP address there's a space, and then after that the net mask is there. So then configure the IP address and subnet mask for the switch in this way. Then you have to give a no shutdown, so that is administratively enables the interface. So that's why we give a no shutdown. And switch still need to have physical ports configured and the VTI line to enable the remote management. So the interface addressing verification, we can use a show command to verify the interface, and we can give show IP interface brief. So then you can see what are the interfaces that are available, and then you can see that the assigned IP address of the VLAN 1, and then show interface brief. You can see the other configuration in another device. So this is how the end-to-end connectivity test. So when we connect two devices, and if you want to ensure that these two devices communicate with each other, so the very primary test that we can run is the ping test, PINT. Please excuse me, I got I'm getting a call from London Tech. I'll come back soon, right? I got a call from London Tech, and I think you have a student meeting, right? Do you know the time for the meeting?
Yes, I think it's 2:30, right? With
Yes,
the
2:30.
UK
Yes.
representative.
Yes. So be careful when you are attending the meeting and answering to the question that they ask, right? Because if you have any problems, you can separately discuss with the London Tech. But when it is an open meeting from a university, so we have to be carefully answer to their question, because they are very friendly. They are asking questions, but ultimately the decision that they are taking on behalf of the students will be sometimes not favorable. So therefore, it will be impact to all the students. So therefore, whenever you are telling something, sometimes it might be personal, but you have to think about that. If you tell something personally, so then it might be affected, impact to the whole batch. So therefore, carefully answer to the questions. The better to answer the questions if it is necessary. Otherwise, better to keep it quiet if you don't know exactly how to answer to that question, right? So in that way, please manage the particular student meeting. So then after that, we have a staff meeting to discuss the issues what they have with the academic activities. So therefore, according to the meeting that the student with the student they have will be depend the staff meeting, right? So therefore, very intelligently you respond to it. Better to give the chance to the representative, because he knows how to handle, and also he has aware by the London Tech to represent that batch. So therefore, better to give him the chance and keep the others quiet without creating unnecessary problems, right? So that is the best way of doing it. So otherwise, sometimes in previous batches, certain problems came because of unnecessary hints gone to them. So therefore, you better to keep in mind that before attend to the meeting. Okay. So I believe we will give that help, so then we can manage it in favor of your side, right, in the staff meeting. I think already you know about it, no? Just time delivered the message from London Tech. Yes. Are you all aware about it? And do you have representatives also already appointed, no?
Yeah.
Yes, already one guy has been appointed for the as a representative, and we had a meeting. I think 3 days back regarding this one.
Okay.
Mr.
Then you
Jesus
know,
Nagaki.
all you know aware about it, no? All you aware about it, no?
Most of us aware, yes.
Okay. Please, if the representative is there, you can acknowledge all the members of the batch, and you can prepare them for facing the meeting in the right manner. Okay. Thank you for your time, and so we'll go back to the presentation, the lecture, right? So we were discussing about how to test the connectivity of two devices. Let's say we have two routers, we have connected it, and we want to know that whether they are communicating each other. So in that case, the primary command that they are using in networking is ping command. That is 192.168.10.2. So then you can send the ping command to that IPs which you have configured already. So then you can see the continuous ping. You can see that the four packets come go a trip and come around, and it says that from where it is came and how many bits it has been used and the time it has been taken. So if there is any abnormal delays, so the time and the time will be show you what will be the delay, maximum delay that and the minimum here, right? So then you can get an idea about it, and also it says how many packets were lost, right? So then he has sent 4 packets and received 4 packets, so no lost, right? So then the communication is, the connection is stable. Here also like this, right? So it's a good test for connectivity. So that's what I have to highlight in configuration modes, right? So then I'll come back again to my previous slide because now you are aware about the standards that you have to maintain when you are doing configuration. Oh, I'm sorry. Just now I came to know that 10:30 you have a class. Sorry for the inconvenience. So thank you very much for being with me for a long this time. So we'll meet again on next Sunday or Saturday, right? If I put a class on Saturday, is it okay again? Extra class? Hello? Okay. So we'll discuss later because you have got late already, 10 minutes, right? So then I'll inform you. Okay. Thank you very much for being with me. Right. Bye. See you again.
Thanks.
Thank you.